Practice exercise 16.9 stutter is asking us to write a method stutter, and it doubles the size of a list by replacing every integer in the list with 2 of that integer. So let's look at the following example here. After a call to list.stutter, the previous list is going to look like this. Pretty simple in explanation. Now let's execute it. We can assume that we are adding this method to our LinkedLists class as defined below. So we have a public class LinkedList where we have a private ListNode front. And this is going to be the front of our list. So it's going to store the value 1 as well as a pointer to the next value inside of our list. Let's start this out. It's going to be a public, since we're just modifying, not returning anything, void, stutter, parentheses, and a bracket or a brace. Anyways, we're inside of this method now, so now we can code. So we know the front is the head of our list, right? Let's make a current value to store the front. Let's make a node value to store the front of the list and the pointer. So let's do ListNode, and we'll call this current, and we'll set it equal to the front value. That's going to store the very first value. Now we want to look at every value within this list. So while our list is not empty, or while our current does not equal to null, so current, oh, I'm doing this wrong. I'm doing it like I think it's a variable. It's going to be like this, not the other way around. So it's not current dot is empty or whatever. I was thinking not variable, but like a stack or a queue or something. This is different. It's a list node. So while our list node, which is current, does not equal to null, and remember, front is going, or current is going to be storing this first value and the pointer to the next one. So eventually, while we run through this, we're eventually going to hit this last value, and then the pointer for it, and the pointer, once we go again, is going to point to null. And that is when we'll break out of our while loop inside of here. So inside of our while loop is where we are going to want to set the duplicate value and then move the pointer over to. So we'll say current.next, because currently we're looking at the first value. We want to set the next value, right? Because and it allows us to do that because we have this first value and the pointer to the next value. So current.next is equal to, we're passing in 2 values here with a new list node. So we want to make a new list node. We have to pass in our current value as well as a pointer to the next thing. So we're going to do current.data. So our next value from here is now going to have this 1 in it, because it's copying the current data value into the current.next. So this is the data being stored in this very next value, and this is creating the link to the next node. Now that we have that done, we have the value and we have the link, which is super important. We can set our current value equal to, and because current is currently still equal to the front right here, we want to set it equal to not the next one, but the next one after that. So current is going to be equal to current.next.next. And that's pretty much going to be it. That'll conclude our while loop, and that'll conclude our method right here. Pressing submit, that passes 5 out of 5 tests. So that'll be the code, the normal code for this problem. If you want to see it done in recursion, check that playlist in the link below the like button for part 2, where I do this recursively, as well as other practice problems to help you with your studies.